Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Today we're diving into something that sounds like science fiction, but exists right now. AI that can read your infrastructure metrics like language, explain anomalies in plain English, and predict failures without being trained on your specific data.
And the weird part? Even the companies who built this technology won't use it in production yet.
Wait, seriously? We're talking about real tech that's already released, not vaporware.
October 2025, Stanford releases OpenTSLM. May 2025, Datadog releases Toto, trained on 2.36 trillion observability data points. These are foundation models for time series data, just like GPT is for text.
Okay, so paint me the picture. What does this actually look like in practice?
Imagine it's 3 a.m. Your Prometheus metrics detect a latency spike. Traditional monitoring sends you an alert that says latency exceeded threshold. You wake up, check Grafana dashboards, correlate metrics manually, dig through logs for 30 minutes to figure out what happened.
Yeah, I've been there many times.
Now, imagine your observability platform reads that spike like a sentence. It understands what the pattern means based on your entire infrastructure history. It tells you in plain English. This latency spike correlates with database connection pool saturation based on similar patterns in 47 historical incidents. Recommend increasing pool size from 100 to 150 connections based on current traffic growth of 15% month over month.
That's exactly what I need at 3 a.m. Natural language, root cause analysis with specific recommendations. So why aren't we all using this?
That's the mystery we're unraveling today. Revolutionary technology that exists but sits on the shelf.
All right, let's start with the basics. What are time series language models? Because I know what time series data is, I know what language models are, but together...
So you know how LLMs conquered text with GPT, then images with DALL-E, audio with Whisper, video with Sora? Each time, it's the same foundation model paradigm. Train on massive datasets, get zero-shot capabilities, transfer learning across domains.
Right, and that's what makes them powerful. GPT-4 works across tasks without fine-tuning because it learned from such diverse text.
Exactly. TSLMs bring that same paradigm to temporal numerical data. They integrate time series as a native modality alongside text. So instead of just processing words or images, they understand trends, seasonality, anomalies in metrics, and can explain what they're seeing in natural language.
Okay, but how? Because metrics are numbers over time, not text tokens.
There are three main approaches. First, quantization. Convert time series values into text tokens that the LLM processes, like turning CPU at 45% into a special token representing mid-range value.
That sounds like you'd lose numerical precision, though.
You do. Second approach is soft prompting. Embed the time series into continuous vector space. Concatenate with text embeddings, and the LLM processes both jointly. That's what OpenTSLM's soft prompt architecture does.
And the memory requirements?
110 gigabytes of VRAM for soft prompt, which is why they built a third approach. Flamingo uses cross-attention. Time series gets its own encoder, then cross-attention layers bridge between time series and text, more memory efficient at 40 gigs.
Still, 40 gigs, that's not exactly running on my laptop.
No, but it's the best we've got, and the performance is genuinely impressive. OpenTSLM on sleep staging. 69.9 F1 score versus 9.05 baseline. That's a 7.7 times improvement.
Sleep staging? I thought we were talking about infrastructure monitoring.
That's the thing. OpenTSLM is medical-focused right now. Sleep analysis, ECG, human activity recognition. But the architecture is domain-agnostic. It's designed for any temporal data.
So someone just needs to apply it to infrastructure metrics.
Someone did. Datadog built Toto, time series optimized transformer for observability, trained specifically on infrastructure and observability metrics.
How much data are we talking?
2.36 trillion data points. That's the largest data set for any open weights time series foundation model ever created.
Trillion with a T, and performance?
0.672 SMAPE on observability data. Best among all time series foundation models. It outperforms Google's TimesFM, Amazon's Chronos, Salesforce's Moria, specifically on infrastructure metrics.
Okay, so let me get this straight. Datadog built the world's best observability AI, trained it on 2.36 trillion infrastructure data points, achieved state-of-the-art performance, and then what? They're not using it?
Direct quote from their blog. Toto is still early in development and not currently deployed in production systems as we focus on thorough testing and product integration.
That's the mystery right there. If even Datadog won't deploy their own cutting-edge observability AI to production, what are they waiting for?
That's what I wanted to unpack. There's a third player too, TimeGPT from Nixtla, released in 2024, trained on about 100 billion data points across finance, transportation, web traffic, weather, energy.
So OpenTSLM is research-focused on medical, Toto is observability but not deployed, and TimeGPT is...
General-purpose forecasting with commercial API. It's actually production-ready with SLAs and support contracts, but it's limited to forecasting. Doesn't do the full observability stack like anomaly detection or root cause analysis.
So we've got 3 models, 3 different maturity levels, but none doing what you described at the beginning, that 3 a.m. root cause explanation.
Not yet. And here's where it gets interesting. The technology works. The benchmarks are real. So what's actually missing?
Let's talk performance. Because works in research and works in production at 3 a.m. are very different things.
True. And there's a study from December 2024 that's revealing. Time series foundation models, quote, struggle to capture task-specific nuances required for effective anomaly detection.
Meaning?
Traditional methods, XGBoost, autoencoders, frequently match or outperform TSLMs on anomaly detection tasks. The foundation models are good at general patterns, but miss the specific edge cases that matter for alerts.
So if I'm running mission-critical alerting, traditional methods are still more reliable.
As of late 2025, yes. But here's the trade-off. TSLMs are easier to use because they're zero shot, no training required, and they give you natural language explanations.
That's valuable for humans understanding what happened, even if the detection accuracy is similar to traditional methods.
Exactly. Traditional methods might say anomaly detected with 95% confidence. A TSLM says anomaly detected, and here's why. Pattern matches these 17 historical incidents, likely caused by X, recommend action Y.
I'd take explainability over 2% accuracy gain any day. But you said 40 to 110 gigs of VRAM? What's that actually cost?
Self-hosting means $20,000 to $40,000 in GPU hardware. And inference latency is seconds to minutes, not the sub-100 millisecond you need for real-time alerting.
Versus traditional methods that run on commodity hardware with millisecond latency.
Right. And then there's the expertise problem. To actually use TSLMs effectively, you need knowledge across 3 domains.
Let me guess. Time series fundamentals, LLM concepts, and infrastructure domain knowledge?
Exactly. seasonality and trends, transformer architecture and prompt engineering, Prometheus and Grafana and SRE practices. How many engineers have all three?
Not many. So even if I had the hardware, I'd need to hire or train for this very specific skill intersection.
Which brings us to what's actually missing. It's not that the technology doesn't work, it does. It's all the production infrastructure around it.
Meaning vendor support, battle testing at scale, integration ecosystem.
Yeah, there's no Prometheus exporters for TSLMs, no Grafana plugins, no Kubernetes operators. You'd have to build all the integration yourself.
And unknown failure modes. When GPT hallucinates, you get weird text. When your monitoring hallucinates at 3 a.m.,
You might ignore a real incident or wake up the team for a false positive. The false positive rate isn't well characterized for TSLMs yet. That's critical for alerting. Alert fatigue is already a huge problem.
plus, foundation models are black boxes. If my traditional anomaly detector fires, I can debug the algorithm. If a TSLM fires, how do I know why?
Explainability paradox. They can explain the anomaly in natural language, but you can't explain why the model made that decision in the first place.
Regulatory nightmare for anyone in FinServ or healthcare. So what's the actual timeline here? When does this technology become production ready?
Based on what Datadog's saying and the current maturity, I'd estimate 2026 to 2027 for vendor integrations.
Meaning Datadog releases Toto as part of Watchdog, other observation platforms follow?
Exactly. They're doing thorough testing and product integration now. First production deployments, case studies, battle testing, then commercial TSLM services launch.
And mainstream adoption?
2027 plus. That's when you get mature Prometheus exporters, Grafana plugins, production proven at scale, becomes standard platform engineering practice.
So if I'm a platform engineer listening to this in late 2025, what should I actually do? Because this sounds important, but not ready.
That's the key question. And the answer is prepare, don't implement. 3 areas to focus on.
Skills first, right? What should I be learning now?
Time series fundamentals. Make sure you really understand seasonality, trends, stationarity, forecasting metrics like MAE and SMAPE. There's a good book out, Time Series Forecasting Using Foundation Models from Manning 2025.
What about the LLM side?
Learn transformers, attention mechanisms, prompt engineering. You don't need to implement them from scratch, but understanding how they work helps you use them effectively. And that knowledge is valuable regardless of whether TSLMs take off.
Because even if TSLMs don't become the standard, LLM concepts are everywhere now.
Exactly. And then deepen your infrastructure domain expertise. The better you understand what questions to ask about your metrics, the more valuable any AI tool becomes.
Okay, skills make sense. What about hands-on experimentation?
3 levels depending on your resources. Lowest barrier, sign up for Time GPT API, forecast some non-critical metrics compared to a profit baseline, just to experience zero-shot forecasting.
That's the commercial API, so it costs money, but you don't need hardware.
Right. Medium barrier, download Toto's open weights model from Hugging Face, run it on dev or staging observability data, benchmark against traditional methods. You'll need some compute, but it's educational.
And for research organizations?
Clone the OpenTSLM repository, try to adapt it to infrastructure metrics that requires ML expertise, but if you've got it, you're exploring the cutting edge.
All of these in non-critical environments only.
Absolutely. This is learning and positioning, not production deployment. You're building skills so when vendors ship production-ready versions, you're not starting from zero.
What should we be monitoring? How do we know when it's actually ready?
Watch for vendor announcements. Datadog Watchdog, integration with Toto, Grafana AI features roadmap, any observation platform announcing TSLM capabilities.
And the signal that it's production ready versus just marketing?
Look for public case studies from organizations similar to yours. SLAs and support contracts becoming available, false positive rates being published and characterized, integration ecosystem maturing, actual Prometheus exporters, not just APIs.
So, the green lights are vendor production integration, case studies, SLAs, characterized performance, mature integrations.
Exactly. And the red flags are only research papers with no deployments, alpha or beta labels, no SLAs, and critically, the vendor hasn't deployed to their own infrastructure.
Which is where we are now with Toto. Datadog built it, but won't use it themselves yet.
Right. That's your clearest signal. When Datadog announces Toto is now powering Watchdog in production, that's when you know it's ready.
All right, so give me the conservative playbook. Timeline for how a platform team should approach this.
2025 to 2026, develop skills, experiment in non-critical environments. Read the books, try the APIs, understand the concepts.
While monitoring vendor announcements.
Exactly. 2026 to 2027, pilot vendor solutions when they become available. Join beta programs, test and staging, prepare for production.
And actual production deployment?
2027 plus, after it's proven at scale. Wait for battle testing, case studies, mature integrations. Don't be the guinea pig for your monitoring stack.
Because if our monitoring fails, everything fails.
Exactly. This isn't like trying a new CI/CD tool where worst case you roll back. Monitoring is foundational.
Let me bring this back to that 3 a.m. latency spike we started with, because I think that scenario captures both the promise and the reality.
Yeah, that scenario will happen. AI will eventually read that spike, understand the pattern, explain the root cause in plain English. But today,
Prometheus and Grafana and solid alerting are still the right answer.
and that's okay. The smartest move isn't rushing to adopt unready technology. It's positioning yourself to lead when it matures.
Build the skills now. Time series fundamentals, LLM concepts, deep infrastructure knowledge. Experiment in safe environments. Monitor vendor maturity. And when they ship production-tested solutions in 2026 or 2027, you're ready to evaluate and deploy.
Not just ready. You're ahead of peers who ignored this entirely or wasted time implementing half-baked solutions too early.
The fundamentals remain constant. Good observability practices, understanding your metrics, thoughtful alerting. TSLMs will enhance that, not replace it.
And when they do arrive, the platform engineers who prepared, who understand both the technology and its limitations, they'll be the ones extracting real value.
Not just adopting because it's AI and AI is hot, but because they can articulate exactly where it adds value and where traditional methods still win.
That's the empowering part of this story. Yes, revolutionary technology is coming, but you have time to prepare thoughtfully instead of reactively.
The future of infrastructure monitoring is AI that understands temporal patterns and speaks human language. But the future isn't 2025. It's 2026, 2027, and beyond. And the platform engineers who lead that transition are the ones building skills and experimenting now.
Without betting the farm on unready tech.
Exactly. Prepare, don't implement. That's the takeaway.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.